So hello everyone and welcome again. In this video I will show you the implementation of the list data structure. So let's add a new item, and it is something header file, and we can name it linked list. So can add here. So as we did in the case of this is something defined, if not defined, so we will use the similar thing here. If not define, which one? That means linked list underscore h. That means if this file linked list h, then define linked list underscore h and if. So we will write our class here. So class name is linked list. So let's see the so you can see here in the class implementation your node class was different. You have implemented few functions in the node class, but here we have implemented the node class where we have node class. So our node class is like this one, and again see the linked list. Number of data members are limited, so I just expanded it. I included more data members. Just if you do little practice with having different function members, then you can understand better. So please see linked list. Two nodes, header node and last node. So header node pointing to first node and last node pointing to the last node of the list. So two data members. And then linked list int item, and these are two constructors, and this is one destructor. So one is a destructor to destroy the list. Is empty function, it is a boolean function, and then you can see some getters and setters. Get head pointer, it will return the head node. Get last pointer, it will provide the pointer to the last node. Get pointer to int item, if we provide any data, that mean have if we provide some item, then this function get pointer to will return the pointer to that node. And similarly we have one more function, get position. That means if we have some data in the list, we want its number in the list. Get position, it will give us this item is on 5th place or 7th place or on 10th place or first place, like this one. Similarly we have get size, get size function will provide us the number of elements or items in the list. We can have one more function, get frequency of. That means if we provide some data, how many times this data exists in this list. So number of times. So frequency integer will be returned. So then you can see insert at front, insert at back, insert int position and int item. So we have three functions, different functions to insert the elements, because we can add elements at front end and we can add element from the back end, and at any position we can provide. So the item is provided. So um, um, then you can see here four different remove functions. So remove at front, we can get node. This function will return node and will remove the node from the list and provide that node to you, and you can play with that node. And then we can have another function, remove at back, so from the back side, and remove at int position. You will provide, okay, remove the node at position 10. So the that node will be removed from the list and you will be returned, you will get that node. And remove int item. And the last is something that if you just provide the data, then this function will find the occurrence of this data, first occurrence, and then it will delete that node, and the deleted node will be returned to you. And this function find is, if you give any data, it will search the tree, sorry, the list, and give the answer, okay, the item is found or not found. It is a boolean function. And again, this is something display. As we have replaced this display with the overloading function operator, overloading operator or double angle operator. Similarly, we will replace this display function with we will overload operator for this linked list type. So now you may get idea that I have included so many functions, small functions, and we will implement them, and mm, you will have better understanding of list data structure. So let's now implement one by one. So um, let's see, we have two parts, private part and public part. In private part we will have two nodes, node pointer, so head ptr. So this is something head pointer, pointer to first node, pointer to first node in list. And again we have another node, last ptr. That is something pointer to the last node. And before it we also need to include here node.h. So in public section we will have um, linked list constructor. So this is something a default constructor or um, constructor without um, any argument. So we have defined this the we have here prototype of this one. So this is end of the class, so we can have implementation here. So resolution operator, then this is the function name, and here we can have body. It is very simple. So we can have just a head pointer, null pointer, null ptr, and last ptr we have null ptr, null pointer. So it is something end of constructor, end of constructor. So we have implemented the constructor, and then uh, we may have a very small very simple functions like setters and getters. So we have two data members, so we need getters and setters, right? So let's see. So void set head ptr. So they need a node pointer p, suppose, and here we can have here um, set pointer, set head pointer, setter, one setter for a head pointer. So similarly we can have, I can copy this one, set last ptr, last pointer, and we will provide a pointer and it will set for the last ptr. And we will have some getters, get head ptr, and I can write here const keyword. So getter for head ptr, and get last ptr again I can have here const. So this prototype is for getter for last PTR. So we can implement them. Implementation is very simple. So here is their body, and we need to add here. So after return type is void and linked list, and then we have we will be given some pointer, and we will just in the body we will just head PTR will be assigned a value of p. So here end of set head PTR. Similarly, if I copy this one, so then last PTR, it is something last PTR, end of set last pointer. So very simple functions. Similarly, we will have let me copy this here. This is something, please see the header line for the function, and after this one we will have body, and body is just return head PTR. So end of get head PTR. So last PTR, return last pointer. So so we will have some more simple functions. Int get size. So return, this function will return number of elements in the list. So here we will put semicolon. So this function we will define here. It will provide it will return, and this function is belong to linked list, and here it is body. So what is the statements in the body? What are the statements? So we can have return, and also we can put here const, and we can also put here, that means it will not change any data member. Return head ptr equal to null ptr. So if head pointer is null pointer, that means there is not a sorry, it is something is empty function. Get size is something different. So this body is for sorry, so this is something for is empty, is empty, is empty, and boolean. So let me write here int get size. So let's see get size function. So let's we create one node pointer. This is something okay, current ptr, and we assign it head ptr. So head ptr, so we have created one node current ptr, and current ptr and head pointer are pointing to the first node. Then we have an integer I and equal to 0, and then we have a while loop while current ptr not equal to null ptr. So then we have some loop. In this loop we will move this current ptr. It will be current ptr and get link. So it will move to the next node get link, and then also we have I plus plus, and then we can have here return I. So this is something get size function. So let me and the empty is empty function we can have here. We need to have here boolean is empty and const. So returns 1 returns true if list is empty, otherwise false. So we can have implementation here. So here end of is empty, and here end of get size. So let me copy these For your reference, I will upload this implementation on EL site, so you can just find here. So this is something, a body of get size function. So we have implemented these functions, and now we can have um, some more functions. So let's say, oh, this is one mistake, spelling mistake here. So um, we also need one destructor linked list, so we can have here so um, we can define here so this is the name of the destructor, and its body is something like this one, so we can have we can call one function clear function, right? So this is very simple. So we will write a clear function. So and it's end of so here this is something destructor. So then let's say let's write here clear function. Clear function is here void clear, so it will delete all nodes, it deletes all nodes from the list. So let's define here so this is something, and here we will have its body clear function. So we will create a node temp ptr temporary node, and we can assign it. So please remember, we can do this thing. We can do the because we also have um, mm, so get head pointer function. So you can use this get head pointer function. So we have this getter, so it will return the same thing. So you can use any one of them. Then um, while head ptr is not null pointer not equal to null ptr, then we have some loop, and body of the loop is here. So head ptr, it is something move next ptr get link, so move next, and then um, we can have temp ptr, it is set link null ptr, and delete temp ptr, and then tmp temp equal to head ptr. So tmp temp tmp tmp. Okay, so uh, we will move from the head pointer to the end of the list, and then uh, we will copy the contents to the, not actually we are copying the contents, we are just copying the address. So then we uh, temp pointer pointing to the um, head pointer, and then head pointer is moving ahead, and the behind the temp ptr is deleted. So we can this way we can delete all um, nodes. It's something very simple. So this is something end loop, and while, and here we have end of clear function. So simple. So let's write another function. That function is something get pointer to. So we will get some node, return node get pointer to, get pointer, So this is the name of the function, and this function will take as an integer an entry, and, and it will return the pointer where this entry is in the list. So you will just provide the data, and this function will return you the pointer to that node, that the um, uh, so uh, returns the pointer to the node containing the data, the given data is given an entry. So data, that means something, data. So we can put here const, and we can provide reference, and also we do not want to change any data member. Okay, then just copy. So this is the header, and here we can have control V, and then I can put here, and here body start. So we can have here some boolean function. Found, it is initially false, and then we can create a node current ptr, and we assign it head ptr. So then while loop, while not found, that means not found, and not null pointer, not equal to. So the current pointer, current ptr not equal to okay, let me little bit more clear. So two conditions, right? Then we have this loop. So if an entry, this is something, the entry equal to current ptr get data, if this condition, if found, then found equal to true, else just move current ptr equal to current ptr and get next, get link. So this is something if end of loop, and then return current ptr. So end while loop, and end of get pointer to. So this is very handy function we can use in other functions. So we have implemented it. So then let's have another function, get position. Int get position, and you are provided again the same thing. You are provided this one, and you can put here also const. So it will returns the node node number. That means the first, second, third are node number in the list. Containing the n entry data. So let's copy this one. So here, so we can, so here this should return pointer, so node pointer here. So this is something the here body start from here. So it is something same function. Okay, this is the problem. Yes, this is the problem. So get position int, yes. What is the problem? tmp point. No problem. Okay, so I am just copying the same function. So then I start from one variable pose equal to 1, and then return pose, and if found then we can return pose, if not found then we can have here loop, this one up to here, else part. So we can have I plus plus, sorry, not plus plus pose. So because we have started from 1, so um, so it will return pose, but it is okay if first time it is not found, that mean um, uh, if we need to put some condition, we need to put some condition like this one. Suppose it is not found and the current pointer become null. So in that case we also need to put here if not found, if not found, then to 0. So we can start from 0 and we can have here plus plus. So in the beginning no found, that means false, and then current pointer is header pointer. So if an entry become current pointer, then get data found true, then it should return 1. How to handle the first entry? We start from, I think that is better. I think this is something, if one, if found, if found first time we can get 1 and we can increase like this one. That is okay, that's fine. I'm sorry. So if not found, then position is a 0, return pause. So this is very handy function again, so we will use it in our other functions. So end of get position. So then let's write one more function, that is something um, get node at. So get node at, so that means we are interested in getting node. Oh, sorry, that this is the proper place here. We are interested in getting the node get node at, and some position is provided, some position is provided. Okay, so returns a node pointer for the given node number. If node number is 10, then it will provide the node number at position 10. So we can put here const. So let's see, copy this header resolution operator we need to put here, and then this is the body. Okay, so we can have node pointer, it is something the current PTR and equal to head PTR, so we can put like this one, and then we can have some for loop int I equal to 1 and I less than position and I plus plus. So then current PTR equal to current PTR and then get link. So this is something the for loop, and return current PTR. So this current pointer is, so this is something end of get node at. So before going to this one, let's see if we can put some condition here. If uh, if list is empty, if list is empty, or we can put one more, or our position is greater than get size. If any one of this this thing happen, then current PTR equal to null PTR. Else we can have this for loop. So we can put this condition. So it is also possible that you can put this one here. See before, and here just a new node, just you can create some new node. So this is something for loop. So then you can run this for loop onto position number. So also this one is a very handy function. Okay, let's now we uh, we can have some more functions, and here void insert at front. This is some function that will take some argument. Argument is something an entry, so we can put, as we used to do, const, and here we can have something like this one. So we can have some and here we can an entry new item actually we want to add. So it will add adds the node at the front of the list. That means first element will become the second element, and this node will become the first node of the list. So this is something that we want to do.